Okay, welcome to our third lesson on trigonometry. And in this lesson we're going to start to learn how we can use some basic ideas to work out some lengths of triangles. And in fact we'll start to learn how we can use trigonometry to for example, work out the height of a tree that we couldn't actually physically measure. So let's get into our lesson. Just to recap a couple of ideas. Firstly, this is what we learnt about last lesson, which is called the unit circle. So we'll just write that down again. This is our unit circle. And remember, the unit circle is a circle that's drawn on top of a set of Cartesian axes, in other words, an X and Y axis, and the radius of our unit circle is 1. So it has a radius of 1 unit. The radius equals 1. Okay. So, the other thing that we started looking at in our last lesson was the sine and the cos button on your calculator. And we started to suspect, by looking at some of the values we're getting, there was a connection between the value along here, these values here, and the sine and the cos of the angle. So let's explore that just a little bit more now before we move on. So what I want to do then is we're going to draw in another angle, and this time we'll draw an angle of 60 degrees. And we'll draw it in blue. So always draw, when we're drawing an angle on our unit circle, we always draw it from the center of the circle. So there's the center. Drawing until we hit the edge of the circle, like that. Okay, and that angle in there is 60 degrees. So we'll just mark that in as 60 degrees. Measured from the horizontal, measured from this X, that's our X-axis, remember? So measured from our X-axis, okay? So we measured from that line around to there, and that's 60 degrees. Okay, now what I want to do is complete our triangle. Remember, this is all about triangles. So we're going to now complete the triangle. So we want to make a right angle triangle out of this line. So we will try to very carefully, accuracy is really important here. So we'll draw our vertical line, or the height of our triangle, about there, and it's probably about right. Remember, this just be an approximation. Try to be as accurate as you can, though. So here we go. There's the height of our triangle, and there's the there's the base of our triangle there. Okay, so we've drawn our 60-degree angle on our unit circle, and we've completed the triangle. So here's our angle. Let's mark our angle in. There it is there. There's our angle. The next thing we need to do is label our triangle: hypotenuse, opposite, and adjacent. And I'm pretty confident that you can do that now, so you can go ahead and do that. Alright, so hopefully you would have realised that this is our right angle, of course, in there. So the side that's opposite the right angle, which is the longest side of our triangle, is called the hypotenuse. And remember, in this triangle, the hypotenuse is the same as the radius of the circle, which equals 1 unit. There it is, 1. This side here, this height of the triangle, the vertical side, is opposite our angle. It's opposite, so it's called the opposite. So that's the opposite side of our triangle, and the remaining side is the adjacent, the side that's next to our angle. So hypotenuse, opposite and adjacent. Now the next thing is I would like us now to look at the sine and the cos of this angle. So we'll go with that colour, I think. Yep, okay. So let's look at well, actually, before we do the sine and the cos, let's estimate the height and the base of our triangle here. So let's estimate the height first. So, or the length of the opposite side. So we're going to estimate the length of this side. So I'm going to bring my ruler in, and I'm going to draw a dotted line across there, about there. And now I'm going to try and estimate that. Well, this is 0.8. That's 1. That's 0.9 there. That's 0.85. 0.8. That's roughly about 0.87. So that value there would be roughly 0.87 according to my graph. Although that is an approximation, but we'll see how we go. So I think that our opposite, the height of our triangle, is about 0.87 units. Let's now do the same with the base of our triangle, or the adjacent side. Let's estimate what we think it is. Well, we'll go to blue, I think, and that looks pretty close, 0.4, about 0.5. It's about 0.5 units. Okay, so we think that our adjacent is about 0.5 units long, and our opposite is about 0.87 units long, and we know that our hypotenuse is 1. Okay, so let's now use the sine and the cos to see if we can actually get a more accurate value for this. So what I now want you to do is to use your calculator and work out the sine of 60 degrees. So sine of 60 degrees, and if you work that out on your calculator, you should get a value of 0.866. Now, 866, gee, that's almost 0.87. Gee, our estimate was pretty close. So the sine of 60 degrees, this is telling us the height of our opposite. So when we type the sine of 60 degrees into our calculator, what it's telling us is the height of our opposite side of our triangle, provided that the triangle's drawn inside the unit circle. In other words, it's got a hypotenuse equal to 1. So it's telling us, our calculator told us that height there is 0.866. So let's try the cos of 25 degrees. So we'll just, there we go, change our colour. So the cos of 60 degrees, and if we type that into our calculator, you should get an answer of exactly 0.5. Guess what? That's exactly what we got here. So it looks like the cos of the 60 degrees is telling us the length of our adjacent side of our triangle. How about that? So using the sine and the cos button on our calculators is basically measuring, it's giving us the length of the opposite and the length of the adjacent of the triangle we've made, provided the triangle has a hypotenuse of 1. Okay, so let's do one more just to confirm that. Okay, so we will draw one more angle, and this angle will make this, we'll make it 15 degrees, I think. There we go, 15. So we'll draw our angle first. There it is, to the edge of the circle. Now we construct our triangle, trying to be accurate. So there's the height of our triangle, and there's one side of our triangle, and here's the other side of our triangle. No, I won't draw it there. I'll move it up a little bit. So there's the other remaining side of our triangle. Okay, there's our right angle. We said the angle was 15 degrees, so we'll mark that in like that. There's our triangle. Okay, let's label our triangle again. So here's our right angle. This is the longer side. We know that's called the hypotenuse. And once again, the hypotenuse in this particular triangle, because it's drawn inside the unit circle, has a length of 1 unit. The side that's opposite the angle is called the opposite, so we label that O, and the remaining side is called A, the adjacent. Okay, so let's firstly do our estimates. Let's estimate the length of the opposite. So we'll go with green again. So the length of the opposite, we think, we'll do the opposite first. So I'll get my ruler in. We need a ruler just to mark out where we think it hits the axis there. Quite tricky to get it parallel, but anyway, that's not too bad. So we'll draw a little dotted line across there. So that value there, if we read that value across, 0.2, well that's 0.3 there. So that's halfway between, that's about 0.25. So probably about 0.25, 0.2, 0.3, maybe 0.7. So maybe that value there is about, 0.27. About 0.27. And let's do the same with the adjacent side. So we're measuring the length of the adjacent, 0.8, there's 0.9, 0.95, 0.97 or 75, something like that. So about 0.975 or something along those lines. We're probably a little bit out there, but that's the best that we can do. So we think that our opposite length is about 0.27 units. Let's now work out what we think let's see what our calculator tells us. So to work out the length of our opposite, we push the sine button, we use the sine button, this time it's the sine of 15 degrees. So if we do sine of 15, our answer is 0.258, or 0.258, which is sort of close to 0.26. So it's in the ballpark. We're perhaps a little bit out there, but we did the best that we could. So this is why we use a calculator, of course, for greater accuracy. So we're pretty much in the ballpark there. Okay, let's try our luck with the length of the adjacent, and you can probably remember what we do now. We use the other important button, which is our cos button. So the cos, and this time it's the cos of 15 degrees. So we want the cos of 15 degrees, and if we do that, we get an answer of 0.966. Now you can see that's a little bit lower than this value, but it's still pretty close to the ballpark. That's approximately 0.97, and our estimate was 0.975. So we've done pretty well, really. So once again, the sine of the angle is telling us the length of the opposite, and the cos of the angle is telling us the length of our adjacent for a triangle which actually has a hypotenuse of 1. So let's now just finish up by summarizing those key points. So, when we draw a right-angled triangle inside the unit circle, like the examples that we've done, I'll just put that in brackets, like the examples we have done, then the following really important relationships apply. Then the following. And I'll do these in different colours just to really make them stand out. The sine of the angle, now I'm going to use our symbol for angle, which is theta, so it could be for any angle. The sine of our angle will give us the length of the opposite. It tells us the length of the opposite. And the cos of the angle and the cos of our angle, whatever the angle is going to give us the length of the adjacent. But the one big condition is this. The one condition, the important condition is, we'll do this in blue, provided the length of the hypotenuse of the hypotenuse equals 1 unit. Okay, so you can use your sine button and your cos button to work out the length of the opposite and the adjacent of any right angle triangle, provided the hypotenuse is 1. Now you might think, well, hang on, how many triangles are we going to come across where the hypotenuse is 1? Well, in our next lesson, I'm going to show you how we can use this idea to work out the length of the adjacent and the opposite for any right angle triangle. And it doesn't matter what the hypotenuse is. So we're getting to a point where it's going to become really powerful and really useful. Okay, so look forward to our next lesson. That will be lesson number 4. Thanks a lot.